Yeah, welcome to physics tutorial. This is our second video on conversion of physics equation to straight line form. In the first video, I did an introduction on graph. If you have missed it, you can go and check. And then I gave some examples. So today we're going to look at more examples on transformation of physics equations to graph form. Now, I have three equations here I want to use for the purpose of this video. This is the first equation, the second equation, and the third equation. So I want to transform this equation. Now the variables are L and F. So we are plotting L against F. In the second equation, we are plotting T against L. And the third equation, we are plotting I against R. So when you have physics equations given like this, how do we transform them to plot a graph? So come with me as we try this. So we have L plus C. So now our two variables are L and F, which is this is the y component, this is the x component. Now we are going to transform this equation in such a way that we are plotting L against 1 over F, because there's no way we can plot L against F, so it has to be L against 1 over F. So this is what you do to make no problem. So let me start from. So we are going to move this to the other side. So L is equal to V over F minus C. So L is equal to, now because we are looking for our x component, we have to separate it. So this V, I'm using dots in place of multiplication, 1 over F minus C. The reason why I did this is so that we can equate it to the straight line equation. Based on this, you can see that L is proportional to Y, M is V, X is 1 over F. Then we have, because here is a plus minus, we change this to minus, so C, right? So our Y component is L, our X component is 1 over F, where our slope is now V, and then the graph will have a negative intercept, which is the same thing as C. So our C is equivalent to, so the graph will have a negative intercept. So that is that for this. Then coming to the second one, this is the period of a simple pendulum. We are plotting T against L here, right? So you can see that L is under a bracket. So in order to do this, we need to take away the square root. So let's try here. We have T all upon G. In order to take away the square roots, according to elementary mathematics, you have to take the square of both sides of the equation. So taking the square of both sides will be T squared is equal to 2 pi L over G. Yes. So having taken the square of both sides, what we want to do is that to cancel this square root, right? But because this square encompasses everything here, we are not going to have that T squared is equal to the square root of 2. The square of 2 rather is 4 pi square. So this square will take away this square root. We have L over G. So remember our variable says we are plotting T against L. So we can't have T against L, but T square against L. So we have that T square is equal to 4 pi square over G dot L. So when we equate it to the straight line, y is equal to mx plus c. Discover that our y component is t squared, our x component is L, and then everything before L becomes our slope. So from this, you can see that the graph does not have an intercept, meaning it's going to start from the origin. So our y component here is t squared, x component here is L. Our slope is now 4 pi square all upon G. So that means after you have done your calculation and you get the value of the slope, you can use the value of the slope to find acceleration due to gravity. And then finally, two variables of I and R. But we can't plot I against R because I here is a numerator while R here is a denominator. In order to do this, we have to take the inverse of this. So let's check here. We have that I is equal to E R plus R. Yes. So to take the inverse of this, so we have that I all upon 1 is equal to R plus R all upon E. So I over 1 is the same thing as I. So we have I is equal to. Now, in the principle that we learned in mathematics about LCMs, we can say this is R over E plus R over E. You can see now. But then our variable from here is I and R. So we have I and R. So you can see now that we have I is equal to, we have 1 over E because I'm separating. So that R times 1 will still give us R. Then plus R all upon E. Good. So we are plotting I against R. So from here, when we equate it to the equation of straight line, mx plus c, you could see now that our y component becomes I, then our x component becomes R, yes, and our slope is 1 over the potential of the circuit. And then finally, the graph is going to have an intercept, which is internal resistance all upon potential. So with this, when you plot a graph, your graph is going to have an intercept. And from the intercept, you can find the value of the potential. From the intercept, you can find the value of the internal resistance. From the slope, you can also find the value of the potential of the cell. So this is that for transformation. Follow us as we do other videos on physics tutorial. Thank you so much for listening. If there's any problem or any question, please help us post on the comment section. Thank you.